as you are trying to figure this out, hold on one second. I'm trying to figure something out. Don't mind me. So if I show you some responses we came up with here, there are a few of you that figured it out. So if you put negative 42 up here and negative 11 here, the magic numbers that work are negative 14 and positive 3. And so these two numbers multiply to give us negative 42, but they also add to give us negative 11. And once you know what the two magic numbers are in your magic X, then you can use those to write the factorization of that polynomial. So all you have to do is just write in X, and then whatever you have here, you can put plus negative 14, or you can put minus 14, and then X plus 3. Here's another person that figured it out. And so just to kind of help you with the thought process on this, one thing you can do is list out pairs of numbers that multiply together to give you negative 42. So 42, I know, comes from 6 times 7. But if I try to add 6 and 7, even if one of them is negative, I'm not going to get to negative 11. But the product of 3 and 14 is 42. So if I want negative 42, one of those would have to be negative. And, it's one of these two ways here. But basically, you're checking the sums. 3 plus negative 14 is negative 11, and negative 3 plus 14 is positive 11. So since this is negative, we have to go with this pair of numbers right here, 3 and negative 14. And so that's why they work. Okay, so sometimes that's a little bit tricky, but the magic X is supposed to help you organize your thoughts and help you when you get stuck or when you make a mistake. So that's what we learned yesterday. And if I come back here to just where the title of our pair deck is, because we split it over 2 days. Our learning goal yesterday was that I can factor quadratic expressions, and that's what we just did in our warm-up. That was factoring a quadratic expression. And then today's learning goal is that I can solve quadratic equations by factoring to reveal the zeros. So we're going to use what we learned yesterday and kind of take it to the next level. So some vocabulary for today, the zero product property. And you might have realized this before, even though you haven't seen it written out this way, maybe, but the zero product property basically says that if the product of two real numbers is 0, then at least one of the numbers is 0. So if you try to think of two numbers that multiply together and your answer would be 0, well, you're kind of stuck to having at least one of them equal 0. You could have 0 times 0 is 0, or 5 times 0 is 0, 1/2 times 0 is 0. But if you multiply by 0, you get 0. There's no other way to get 0 unless those two numbers you're multiplying, one of them has to be 0. So we can use this to solve quadratic equations. And these are the steps we're going to be using today. So yesterday, we were looking at quadratic expressions. Quadratic equations just now means that there's an equal sign, and we have a left hand and a right hand of an equation. So today what you're going to see, step 1 is already done. But if it wasn't done, you would rearrange the equation so the right hand side equals 0. Second step, factor the left hand side. So in step 1, you're going to have on one side of your equation, like x squared plus 3x minus 2. And then on the, it'd be equal to 0 on the other side of the equal sign. So we would factor our quadratic expression on the left-hand side, same way that we were yesterday using the magic X. What's new then is that step 3, we're going to use the zero product property to solve, because if I have two factors being multiplied together and on the right-hand side of the equation it equals 0, one of those factors has to equal 0. So if I set them both equal to 0 and then solve each of them, I now have two possibilities for the possible answer. So we can kind of narrow it down to two possible answers for our quadratic equation. This will make more sense once we kind of see it a little bit. So this slide here, slide 11, there's one example that's entirely worked out, and then we're going to work out one together. So we want to solve x squared plus 5x plus 6 equals 0. In this case, step 1 is already done, because step 1 says get 0 by itself on the right-hand side. So right here, step 1 is done. Okay, 0 is already by itself on the right-hand side. Step 2 is to factor the left-hand side. And so this is what we were practicing yesterday, all that factoring with the magic X. I'm factoring the left-hand side of just this x squared plus 5x plus 6. So if I was to make a magic X to go with it, you know, you could put 6 up here. And then you could put 5, which is the coefficient of the x term, down here. And then you're just thinking of two numbers that multiply to give you 6, but also add to give you 5. On the easier ones, it's 2 and 3, because 2 times 3 is 6, but 2 plus 3 is 5. And that's where x plus 2 times x plus 3 comes from. So that factoring step is done here. And we still have it equal to 0, equal to 0. But now we're moving on to step 3, which is new. And basically we're going to set each factor, okay, x plus 2 is a factor, x plus 3 is a factor. We're going to set each of those equal to 0. You can see here, x plus 2 equals 0, x plus 3 equals 0. And we have or in the middle. That's important, right? Because one of these is going to be true by the zero product property. One of them has to be 0. So if we solve both of them, I can narrow down the answer to two possibilities. That's step 4. Solve each equation for x. Okay. To solve an equation, you can do the same thing to both sides of your equation. Like here, I am subtracting 2 on one side and subtracting 2 on the other side. Okay, and then that's just simplifies to x equal -2. For the other equation, x plus 3 equals 0, you subtract 3 on one side, subtract 3 on the other side. That simplifies to x equals -3. So that's what's new here today. After we factor, we're going to set that into two equations and then solve each of them. And then what I get is the solution. Okay, so the solution to this quadratic equation is that x is either equal to -2 or x is equal to -3. So there's two answers that it could possibly be. And you can always check this too to make sure that it does make sense. If you were to substitute back -2 in place of x, it would go in two spots, right? It would go where the x squared is. -2 squared is 4. If I put the -2 where this x is, I would get 5 times -2 or -10. And then 4 plus -10 is -6 plus 6 is 0. So this is a true value for this equation. It also works with -3. If I put a -3 here and square it, you get +9. Put -3 here and multiply it with 5, I get -15. 9 plus -15 is -6, and -6 plus 6 is 0. So it turns out there's two values of x that can work. One of them is the true value, but they both work for that equation. So that's what we're going to do with this one here together. We're going to solve x squared minus 9x plus 18 equals 0. Going back to the steps real quick, step 1 is already done for us. Rearrange the equation so the right-hand side equals 0. That is already done. So we don't have to worry about doing that first step. Step 2 is to factor. So we are going to factor this. And there's a magic X right here for you to use to do that. So when you're setting up your magic X, the constant that goes on top of the X. So 18 is up here in the top. My arrow got disconnected. And then the coefficient of the X term in the middle, and if you have subtraction, remember you have to include it. That's going to go down here at the bottom of my X. So -9 is right here. I'll write that again. And so now we're trying to come up with these two magic numbers that when I multiply them together, question mark times question mark, it's going to equal 18. But also question mark times question mark is going to, no, sorry, talking faster than I'm thinking. Question mark plus question mark is going to equal -9. Okay, so can you think of two numbers that multiply to give us 18, but also add together, they sum together to give us -9? Mauricio is saying -6 and -3. Let's try it. Let's put -6, -3, -6, and -3. Well, they do multiply to be 18, that works. And they do add together to give me -9, that works. So Mauricio is correct. We have, and it doesn't matter if you write -6 on this side and then -3 over here, or if you flip it around, it's the same thing. But once you've used this magic X to figure it out, now you're ready to write the factorization. So this is step 2, where we're going to write the factorization of that polynomial quadratic equation. So we have, in parentheses, x minus 6 times x minus 3. And it equals 0 in this problem. Okay. So that is step 2 right there. Next is going to be step 3. And so step 3, I come back real quick. We're going to use the zero product property and set each factor to 0. So I need to take the factor of x minus 6 and set it equal to 0. Also take the factor of x minus 3 and set it equal to 0. If the top, there's a question here. It says if the top answer is a positive and the bottom is a negative, both of the possible x values will be negative. Yes, that is true. That is correct. That's something you could generalize when you're trying to figure things out. Yeah. Because you have to think about your integer rules, about adding integers, and about multiplying integers. And there's different rules and different scenarios for what would be what. You know, sometimes it'll be the fact, looking at what you have. If the top number is a negative, the only way to get that is if your two magic numbers you come up with, one is a positive and one is a negative, because that's the only way to get a negative product. All right. So we are going to set, you can drop the parentheses when you do this, x minus 6 equals 0. Or, very important that you write or, and then we have x minus 3 equals 0. Okay, we want to solve this. In order to solve these equations, we're going to just add 6 to both sides. On this first one, plus 6, plus 6. The second equation, we want to add 3 to both sides. Simplifying, we are left with x equals 6 or x equals 3. Okay, so that was step 4. We solved it. Oh, I did not want to do that. There we go. That's your answer, okay? The solution to this equation is that either x equals 6 or x equals 3. And again, you can plug it back in and check that it actually works, and it will. If I replace x, both x's with a 6 and evaluate that, I'll get 0. If I replace both x's with a 3 and evaluate it, I'll get 0. So this is what we're doing today. So we're taking what we learned yesterday, but now we're applying it to not just factoring an expression, but solving a quadratic equation with factoring. All right, questions, you guys, on anything so far? Why aren't they negative? So the solutions turn out to be positive. Question is, why aren't they negative? I'm imagining we're talking about the solutions to this. So when we factored, we figured out that we were going to use -6 and -3 in the factorization. But the zero product property, the only reason I'm able to take each of these factors and set it equal to 0 is because of the zero product property. I know that in order for something times something else to equal 0, one of those two things that I'm multiplying together have to be 0. So I'm going to look at this and say, okay, maybe the first thing's 0, so I'll set it equal to 0 and see what I would get. Only way that could happen for x minus 6 to be 0 is if x is actually 6, because 6 minus 6 is 0. The other possibility is that the factor, the entire factor of x minus 3 is 0. The only way that equals 0 is if x is actually 3, because 3 minus 3 is 0. So one of those have to be 0. They could both be 0, but we need at least one of them to be 0. Hope that helped, Mauricio. Okay, cool. So I am going to put you on your own pace, and you're going to do the next slide. And I'll give you feedback on the Pear Deck as you do this, but you can stay on the meet and ask questions or ask questions through GoGuardian.